Hi guys, Raz here. Today we'll be looking at composite functions. So in the previous video, we explained what a function was and some of the uses of the notation. So now we're going to extend that and find what a composite function is. So if I give you two functions, say the first function is 3x plus 1. Now we can't call the second function f again because we'll get confused. We've already called something f. So we're going to go for the next letter in the alphabet and call it g of x. So what you might be asked to do is evaluate or find fgx. So let's recap what we would have done if we were doing f of 2. Let's use a bolder font. Sometimes it comes out naff on the videos when I play them back. So let's do f of 2 of 3x plus 1, yeah? So I'm subbing in 2 for x. So we replace x with 2 and we get our answer of 7. So with that same logic here, what we've done is essentially replace the x in the f with g of x. So this time, I'm going to sub in, I'm going to replace the x here with the whole of g. So this whole thing here will get subbed in to replace the x. So f of g of x equals 3 bracket 2x minus 1 plus 1. Yeah, because f was 3x plus 1, and we're replacing this with what g is, which is 2x minus 1. So that gives us 3 times 2x minus 1 plus 1. Now, be careful when we're simplifying it. So we get 6x minus 2 is fgx. Yeah? So let's have a go doing it the other way. What about finding gfx? Give this one a go. All right, welcome back. So this time we're subbing in f into g. So g is 2x minus 1. F is 3x plus 1. And we want to sub f into g. So that means this f here has to replace that x there. So g of f of x is equal to f into g, so 2 times 3x plus 1 minus 1. So this time we have 6x plus 2 minus 1, which is 6x plus 1. Job done. Yeah, so let's explore that a little bit more. And I have a few questions here that are from exams that we'll just look at. So let's have a look at this one first. Oh, I've given us some nasty ones. I picked a nasty one. So this is a bit different to what we had because now we don't have a letter, we've got the number. Alexa, stop. Sorry about that. So we're going to stub the 2 into the G and then that result into F. So always with these composites, we work from right to left. So first I'm going to sub 2 into G. So that is 7 times 2 minus 6, which is 14 minus 6, which is 8. So this result now gets subbed into F. So that will go directly into F. So F of 8 is 5 times 8 squared minus 10 times 8 plus 7. So we have 5 times 64 minus 80 plus 7, which is what, 447. Yeah, that'd be right. Yes, so we've just worked from right to left. So when we've got a number, actually, it makes it a bit easier. But sometimes it's difficult because it's not familiar to you. What's our next example? Blah, blah, blah. that is. Okay, next one. Let's bring this to the front. Okay. Let's minimize that one. Chuck that behind. Oops. All right, let's do that. So solve f gx is greater than 0. So obviously what we first have to do is find f of g of x. So to do this, we need to work from right to left. So we have to sub g into f. So g is 2x plus 1, and I have to sub that into f there. So fgx equals 2x plus 1 squared minus 4. So I have a bit of work to do here. So let's use FOIL to expand this. So we have 4x squared plus 2x plus 1, and then minus 4. So therefore, fgx equals 4x squared plus 4x minus 3. Perfect, that's the first bit done. So part A, we've got fgx, I say part A, I mean the first part of my workings. We have fgx equals 4x squared plus 4x minus 3. So this would be towards the end of an exam paper, yeah? So it's going to be quite a few marks if it's this taxing. And we now need to, they've snuck in a quadratic inequality into the question. So now I need to evaluate 4x squared plus 4x minus 3 is greater than 0. So to do that, I need to solve this first. 4x squared plus 4x minus 3 equals 0. So we could use the quadratic formula, or we can factorize. I'm going to factorize this. Either way, pause the video now and solve it whichever way you find easiest. Welcome back. So I'm going to do it by factorizing. So I know 4 times 3 is 12, and 6 times 2 is a factor of 12. So I could factor it like this. Then I can group my factors. So I have 2x plus 3, minus 1, 2x plus 3. So therefore 2x minus 1, 2x plus 3. So the solutions are a half and minus 3 over 2. So if you use the formula, you should have got the same solutions. So that means if we draw a sketch of what we have a curve that intersects the x-axis at a half and minus 3 over 2. And we're evaluating where the curve is greater than 0, which is that bit of the line and that bit of the line, which corresponds to the right of this point and the left of this point. So I know x has to be greater than a half, comma, x is less than minus 3 over 2. If you weren't sure about that final bit, check out my quadratic inequalities video. But that was it. So you can see how they like to use this potentially in exams to bridge a few topics. I think that is everything that I wanted to say about composite functions. It is. I'm going to do a little plenary, which I don't normally do on my videos. Maybe it's something I should do more of. So let's do our plenary. That means just summary, yeah. So if we're given fgx, this means that wasn't a good start. F of g of x. This means substitute g into f, i.e., if fx equals 3x minus 1 and gx equals 5x plus 1, then sub 5x plus 1 in place of x in f of x. So this went in there. and we got 3 times 5x plus 1 minus 1, which would give us 15x plus 3 minus 2, which is that. Had we have been asked to find it the other way round, say g of f of x, then we would this means substitute f into g. Yeah, so this time, this would go in there. So now we've got 5 times 3x minus 1 plus 1, which gave us 15x minus 5 plus 1, which is minus 4. I hope that's been useful. See you again in my next video, which should be inverse functions. See you soon.